Okay, this is problem number 18 on page 200, and this is a scenario where we have two friends, and Lewis is down on the ground, and he throws an apple up in the air to Kim, and she's on a balcony 40 feet above him. So it's given in the problem that he throws it up there at 56 feet per second. It's its initial speed, initial velocity. So Kim misses it on the way up, but she catches it on the way down. So how long is the apple in the air? So in this relationship between time in seconds on the horizontal axis and height, in this case in feet on the vertical axis, we get this parabolic shape, which is the relationship at any point in time we could figure out based on the vertical motion model, which is a quadratic equation, how high the apple is. Or if I know how high it is, I can figure out how many seconds, since time equals 0 and height equals 0, that it's been in the air. So we're going to use the feet, the formula for figuring out a vertical motion with feet as a measurement. So we've got the initial, it's going to be initial velocity times time in terms of number of seconds, minus 16 feet per second squared. So this is the effect of gravity that pulls it down, and this is the initial velocity that's pitching it up. And when this becomes bigger than this, or no, when this becomes bigger as compared to this, we're going to start, it hits its max height and it turns down. So in this problem, the initial velocity is 56, and the balcony is at 40 feet. So I'm just going to put an arbitrary mark here. Suppose that's 40 feet. What we're doing is we're finding how many seconds had elapsed when the apple is 40 feet up in the air, and it passes, it goes above 40 feet, and then it comes back down, and it crosses that balcony again, which is the point where she catches it, and we want to know how many seconds is that. So we're looking for when is the height equal to 40. Okay, so we can solve this equation for t. It's a quadratic equation, so I'm going to get the 16t squared on the other side, minus 56t plus 40 is equal to 0. And I'm going to factor out the greatest common factor of 8. And so can look at factoring this trinomial. It's going to factor pretty easily. My first terms have to be a 2t times a t, and I need a 5 and a 1 in these positions, and so if I put the 5 here and the 1 here, I've got a 2t and a 5t to combine to be a 7t, and it has to be a negative 7t, so those are both negative. So the value of t that makes this factor equal to 0, therefore my equation true, is 5/2, or 2.5 seconds, and 1 second for this other factor. We can ignore the 8 because it's just a constant, it's not a variable t. So what that means is, at 1 second, the apple's 40 feet high on its way up, and then again at 5/2 is 2.5 seconds when it's on its way down. And that's the answer to the question asked. The apple is in the air for 2.5 seconds. If Kim had caught it on its way up, like just reached out and grabbed it, it would have only been in the air for 1 second, but it took more time. It went up and came back down, and she caught it at 2.5 seconds. And that is it.